guys, welcome to Chembusters.
We are going to test whether we can make batteries with lemons and potatoes.
We will be testing them side by side with an actual galvanic cell that we will be making.
Did someone say galvanic cell?
A galvanic cell consists of two compartments, an anode and a cathode. At the cathode, reduction happens to the metal, which is gaining the electrons. This means that the electrode present at the cathode will increase in mass. This is the opposite for the anode. As oxidation occurs, the electrode loses mass as the result of the metal turning into an aqueous solution. This type of cell has a negative delta G, meaning it will occur on its own and does not require external source of energy. In fact, it is often used to power other things.
You might think I've never heard of a galvanic cell before, but it's actually more common than you think. If you haven't guessed yet, a galvanic cell is actually just a fancy word for a battery, and batteries are in so many of our everyday objects like in our phones, laptops, watches, cars, and even more. They all depend on the transfer of electrons from the first compartment, anode, to the second compartment, the cathode.
We know what a galvanic cell is. Let's actually make one.
But first, safety with Caroline.
If you have long hair, tie it back. You'll need gloves. Please use safety goggles. You'll need an apron.
Wait, but not those type of aprons.
These one will work though.
Now
let's start!
We will be using copper as our reducing agent.
And we will be using iron as our oxidizing agent.
Because we didn't have zinc.
So anyways, we're going to pour in 125 mils each.
For the very first time.
Close enough.
And we are going to be adding a salt bridge that is made with an NaCl solution.
And obviously, this is completely new, has not been used a single time. You could tell because it's totally not dyed yellow.
With copper.
Yep, definitely not completely clear.
Yeah.
And now we'll stick in
We
the
are
electrodes.
add the electrodes.
And these electrodes, on this side we have iron wire. The other side we have copper wire. And as you can see, this is our voltmeter, which is telling us how much current is going through.
Now, if you notice, if you take the salt bridge out, you cut the current. It goes back to 0. Keep that in mind, for this will be very useful in our studies about potatoes. Butler, bring the potatoes.
Here they are.
So now we are going to be making a potato battery.
We are going to be needing a zinc nail.
Because we actually have zinc now. And a copper coin. This is a penny.
We are sticking it into the potato.
We'll be sticking it over here.
Oh, okay.
Here, is this far enough?
Having some problem sticking a coin into a potato.
This is why you exercise 1 hour daily, children.
I do that and I still can't do it.
So now we're going to connect both sides of the voltmeter.
There we go.
And look at that, we
getting a
have a
voltage.
current.
We have a current.
We
as
have
you
almost
can see.
1 volt.
Now,
Which,
This is far superior to a galvanic cell.
just make a potato battery.
now,
So, a potato battery is actually existent. It's not a myth.
yes, because the potato actually acts as a salt bridge between both of the electrodes, and the potato also dilutes creates an imbalance between the electrons of the electrodes, which means that the electrons are going to be transferred from one electrode to the other. Butler,
We will be now making a lemon battery. Caroline?
we need to squeeze the juices inside of the lemon by, see, I'm spinning it. Still not working.
Well, there's another thing you can do, and that's rolling it. I've told you this for the past 30 lemons.
And you drop them every single time.
No, the first one was fine.
All the juices are on the table as well.
Well, I think it's in soft now. So
Now
now we
we
can
do.
actually make the battery now that like there's a current to actually, now that the lemon can actually carry a current.
Yes, we're going to be doing the same thing as we did with the potato by sticking a penny inside the fruit. Although potatoes are not fruits, are they?
Potatoes aren't fruits.
Potatoes are vegetables.
They're vegetables. Fine, professional penny sticker.
I'm gonna shake. Can I shake it in?
I already.
Oh,
Yeah,
no,
just
I
make
shove
sure.
it in.
Yeah. Now we have a current.
Wow.
0.88 something current.
0.88 something.
Yeah, I mean that's I
Very
think
stable.
that's much higher than our galvanic cell.
That's true.
You see, a lot like the potato, the lemon also works as a salt bridge. And now that we're talking about acids, the acids inside the lemon actually dissolve a little bit of the electrodes, which also liberate the electrons and create the same electric current as as the potato and the original galvanic cell.
So,
And this concludes our experiments we did today. Now, obviously, as you may or may not be thinking, is our galvanic cell legit? Well, it's not at standard conditions. The solutions we used are 1.0, or not 1.0 molar. One's 0.25, one's 0.1. They're not even the same molarity. So obviously, it's not at standard conditions. The voltage will be different from if it would be in standard conditions.
and that concludes
Our
first
first
and
and
final
final episode
of
of
Chembusters.
Because it turns out that we don't have enough funds to actually continue and we got canceled.
I'm your muffin man. You're my muffin girl.